141. There are different velocities in different mediums. V equal F lambda valid for any type of waves in any medium. Is the velocity dependent on frequency or wavelength? No. Answer is no. These are theory sections. We completed those sections. Answer is no. The velocity of a wave or the speed of a wave is only determined by the properties of that medium. Properties of that medium. You can't change if you can't change the properties of that medium, you can't change the speed. The number B, plot F versus lambda and F versus 1 upon lambda. I hope you have done that part. Question number 141. F B equal F lambda, B equal F lambda. They want us to plot F versus lambda, so I take it V over lambda. This is a constant for a given medium, looks like Y equal M over X. So this kind of graph should be there with the frequency and the lambda. Lambda. F versus lambda. In the second instance, B lambda, it's like a constant. Y equal mx type graph could obtain. It is F 1 over lambda. This is the graph. Right? This is the graph. Write down an expression for the transverse waves in a stretched string. Prove that the equation is dimensionally correct. It's a basic question. I'm not doing that. Number D, plot a graph representing velocity of a transverse wave in a stretched string and the tension of the string. Assume the mass, length, others are constant. V equal root T over M. V squared equal T divided by M. They want us to plot two things. One is V squared M. It looks like Y squared mx. This is the pattern of that V versus capital T, Y squared versus, or the V versus T. This is the graph. Y squared equal mx type graph. Second part, V equal root T over root M. Looks like Y equal mx type graph. V, this is root T. This is the graph of that. These are not difficult things, just to highlight few important sections under the question number 141. Make questions ටික කරලා අපි කරපු theory එක කරලා මේ questions ටික කරපුවාම ඔයාලට ඕනෑම question එකක් කරන්න පුළුවන් වෙනවා oscillation waves යටතේ. සයිකෝන වොර වෙන්න එපා. අනිවාර්යයෙන්ම පුළුවන් වෙනවා. Have a questions, at least you should try those questions first. When the tension on a wire of length 90 centimeters is 80 Newton. So you have a string, particular string, which is 90 centimeter now. The tension is given as 80 Newton. T is 80 Newton. It will undergo transverse vibration with the frequency 256. F equal 256 here. How can the frequency be changed to 384 by changing the length, by changing the force, by changing the length and changing the force? The frequency in this particular case, you have to consider that as a fundamental thing, fundamental frequency. Fundamental frequency, we are referring to the fundamental frequency in this case. If you consider a different frequency harmonic number, I mean, let's say second harmonic, I should compare the second harmonic again. I should consider the second harmonic again to compare. Let's start with the fundamental. V equal F lambda. In the fundamental situation, lambda divided by 2 equal L. So lambda equal 2L. V equal F lambda 2L. F not equal V divided by 2L. If not equal, V means T divided by M 2L. So that sort of equation must be derived first. Actually, if you all are okay with that, you can start with this point. The fundamental frequency is 1 upon 2L T divided by M. So you can start with this location, no problem. For the fundamental frequency, right? For the fundamental frequency. When you look at that equation, the frequency depends on few factors. One is tension, other one is the mass per unit length, and other one is the length. Vibrating segment. Vibrating segment. Part, this is for the part A. For the first part, let's assume capital T and simple M as constant. So the frequency depends on the length, vibrating length. The first instant 256, the vibrating length is 0.9 or 9 centimeter. Let's say number 1. In the second section, let's say the new length would be L0, right? Let's say L dash. Second instant, it is 384. I should consider the new length, let's say L1. This is number 2. 1 divided by 2. When you divide 1 by 2, 256, 384, you get 90, you get L1 here. So L1 you would get 60 centimeter. L1 you would get 60 centimeter, right? 60 centimeter. In the second part, by changing the force, in this case, we have to assume the length, vibrating length, and simple length is constant. For the second part, let's assume vibrating length and simple M as constant. Fundamental frequency depends on the tension. For the first part, 256 proportional root 80, let's say number 3. Second one, let's say it is 384, it is proportional to, let's say T1, number 4. 4 divided by 1, 4 divided by 3, 384 divided by 256, T1 divided by 80, it is root. So from there we can get the answer for the T1. It is 180 Newton. So that sort of question, that sort of answer must be there for the question like this. So we have a certain assumption. Let's assume T and M is constant. In a question, they have to give it properly. The mass per unit length is not changed. It is normally string. Right, 141 is okay. I have done 142 and 143 in my class, no problem. Okay, let's move to 146, question number 146. 146. 145 I did, 147 also did. 146. Priyak, have you done that part? Okay. Okay, there. Right. One end of a nylon rope is tied to a stationary support at the top of a vertical mine shaft 80 meters deep. The rope is stretched out by a box of mineral sample with mass 20 kg attached at the lower end. 20 kg means 200 Newton. 200 Newton. There's a mass of that spring also, it is 20 Newton. There's a mass, because of the mass, there's a weight. Right? It is 80 meters long. If I take length, it is 80 meters long. 80 meters. The geologist at the bottom of the mine signaled to his colleague at the top by jerking the rope sideways. He just jerked it sideways. What is the speed of a transverse wave on the rope? If a point on the rope is given a transverse simple harmonic motion of frequency 2 Hz, how many cycles of the wave are there the rope length? So Lamai, in this question, the tension along the string is not uniform. I must tell you that. The tension is not fixed. Here the tension is a different value. Here the tension is different value. Right? Tension here, how much? What is the tension at that point? What is the tension at that point? What kind of a tension you have at that point? It is 200 exactly. 200 Newton. At the top, what kind of a value it should be? What kind of value it should be? No, it's not 0. What is that value? No, it is not 200 even. At the top, it is not 0. Even it is not 200. It is 220. ආර මතක දන්නේ අපි කළා heavy rope එකක කොහොමද tension එක ගන්න කියලා. එතනදී හැබැයි මේ වගේ object එකක් ඉදන් තිබුණ නැහැ. මෙතනදී tension එක 0. The tension developed because of the mass, because of the weight under that location. For example, the tension at this point, if you forget about this particular mass, the tension at that point is mainly due to the total mass of the string under that location. So when I take the point like this, the total tension is the mass of that. It is the tension here. So you have two tension values. Let's say the T1, let's say T2. T1 and T2. T1, of course, 200 Newton. No problem with that because under this location, you don't have anything. It is only 200 Newton. Here the tension, T1, it is 200 Newton. T2, it is 200 plus 20, 220. 220. So in such a question, we have to find an average tension before come to the answer for the speed. Because we know that to calculate the speed, we want to know the tension value. Without knowing the tension, we can't get into the other part. So we have to know the tension. So what is the tension? Let's say T, it is equal to 220 plus 200 divided by 2, which is 420 divided by 2. What is that value? It is 210. You can answer this question based on 210 Newton. Now we can find the speed, V equal root T divided by N. V tension 210, the mass per unit length. What is the mass per unit length? Simple M equal mass 2 kg divided by 80. 2 divided by 80. V equals. Can one of you tell me this answer? Is at 0.025. I will take that 0.025 ms minus 1. Now, they ask another question. This is for the part A. Part B. If a point on the rope is given a transverse simple harmonic motion with a frequency 2 Hz, how many cycles? We don't know the number of cycles. We don't know. We have to find the lambda. for the part B. V equal F lambda, right? V equal F lambda. The V is 0.025. Frequency is given. It is 2 hertz lambda. Lambda 0.025 divided by 2. Lambda equals 0.0125. 125 meters. If I convert into number of cycles, then number of cycles 80 divided by lambda, we get that answer there. 80 divided by 0.0125. Is that 210 divided by 2 into 80? Is that is this answer correct? I think that answer must be wrong. Or 9, yes, 91.65. 91.65. Then it is 91.65. 91.65. Then what is the value of this? 91.65. 45.8. 85. 82. 82. 45.82. 1.74. 1.74 cycles. 1.74 cycles. We have that kind of cycle, that much of cycles there. Okay, let's move to another question. Question number 149. 149. 149. Look at the question. 149. A string 2 meter long is driven by 240 hertz vibrator at its end. It's a string. The string is vibrated but with 240 hertz vibrator. The string resonates 4 segments. 1, 2, 3, 4. 1, 2, 3, 4. 4 segment means 4 loops. The simple story is that 4 loops, 4 segment. 149. 4 segment means 4 loops. So when you draw the number of loops, draw it properly. These are identical loops. 4 loops. The string 2 meter. What is the speed of the transverse wave on the string? In here, frequency is given. To find the speed, we should know the lambda. Lambda divided by 2. 1, 2, 3, 4. 4 is equal to lambda equal, what is that? 1 meter. V equal F lambda, frequency 240, lambda equal 1, V equal 240, ms minus 1. It is the answer. 150. Question number 150. 150. A string fastened to both ends resonate at 420 hertz and 490 hertz with no resonant frequencies in between that. If I take, for example, if I take this value as Fn, the first value as Fn, 420 hertz, the next harmonic is 490. Fn n plus 1, like 5, 6, 7, 8, like that. No resonance frequencies in between that. Find its fundamental resonant frequency. The fundamental is given by the difference between those two values. Fn plus 1 minus Fn equal the fundamental frequency. So F not equal 490 minus 420, 70 Hertz. We have done that under the theory section. It is 70 Hertz. 151. Question number 151. We have given the note under this section, so no need to write again a note under that question because we have already given the theory behind this section. A violin string resonates its fundamental at 196 Hertz, where along the string must you place your finger, its fundamental become 440 Hertz. You have a violin string, let's say the length of that is L, length of that is L. When it is vibrated like this, its frequency is 996 Hertz. Now the new vibrating segment, I don't know its fundamental, but let's say it's fundamental. The new length would be L dash, right? New length, your finger has to be placed there and you go to pluck it. It is L dash or L1. Frequency, fundamental frequency is inversely proportional to L. We know that it is F naught equal, if you want, you can start like this, F naught equal 2L root T divided by N. T divided by N. So the fundamental frequency is proportional to L. For the first part, 196 Hertz, proportional L. We should know when the length reduce, the frequency increase. For the second part, it is 440. The new length is L1. Let's say number 1, let's say number 2, 151. 1 divided by 2. 196, 440. L dash equal. Anyone calculated this answer? 196 divided by 440. 0.44, let's say 0.45, 45 L. So we have to keep our finger at 0.45 length. This is the answer. Just right there. We need to keep our finger at 0.45 length. 154. 154. 154. Done. The tension in each of two similar wires are 50 Newton. 154. You have two strings. Each one. The tension value is 50 Newton. Similar strings, the same length. When they are 50 Newton. Let's say the string A, let's say the string B. When they are plugged at their midpoint, the frequency of note emitted by them is 250 Hertz. So when they are plugged at the middle, the frequency is 250 Hertz. 250 Hertz. If the tension in one of them, one of the wires increased to 2 Newton, increase by 2 Newton. Now, this particular value is not 50, it is 52 Newton, T1. What will be the beat frequency when both wires are vibrating at the same time? So what happened now, when the tension changing, so you can assume both are vibrating at its fundamental frequencies. When it vibrate, like with the different, when you change the tension value, the frequency would change. How we know that? Because we know that the frequency, whatever the frequency, it need not to be the fundamental, whatever the frequency depends on those three factors, M, L, and T. Since you haven't changed the length, M, the frequency change with the tension value, root of the tension. That means the new frequency, let's say F1. I will take T0, F0. Here it is T1, F1. Frequency, we have to find the new frequency to get the beat frequency. Beat frequency, of course, it is F1 minus F0. We have to find the new tension, new frequency of the string. Let's take the new frequency F1, the new frequency as F1. Let's take the new frequency as F1. F1 proportional root T1. F1 proportional root T1, number one. F0 proportional root T0. Number 1 divided by 2, F1 over F0 equal T1 over T0. T1, it is 52, T0, it is 50. F1 equal 52 divided by 50. F0, it is 250 Hertz. What is this value? What is this value? .02. F1 equal 1.02, 250, 255, right? Yes, it is 255. Now the new beat frequency, the beat frequency equal F equal F1 minus F0, which is 255 minus 250, it is 5 Hertz. Like that, we can find the new beat frequency. New beat frequency you can calculate like this. Okay. Let's move to another question. (155), question number 155. Question number 155. There are a few more questions to be discussed. 155. මඩියල් ඉක්මනට කරනවා මේ questions ඔක්කොම අපි කරන්න try එකක් දෙන්න ඕන. 155. Experiment on vibrating strings are carried out using a sonometer. What is mean by tuning sonometer? What do you mean by tuning? Tuning means arranging the sonometer wire to its fundamental frequency. Vibrating segment has to be placed to fundamental frequency as the source frequency. Right? I have given the note. You should understand it. Just read the note again if you can't understand. Write down 3 methods that you can use to tune the sonometer and explain them. Tuning by listening, tuning by what? Tuning by listening is one thing. Tuning by resonance, tuning by beats. So those are the 3 things. Ne? Tuning by listening, tuning by resonance, tuning by beats. Plot graph representing frequency versus length of the wire. So it's like y equal m over x type graph. You should know that. Plot a graph. Okay. Verse tension. I have done that. Number 5. Sonometer wire resonate with the tuning fork when its length is 80 centimeters. So when you do the questions, make sure always you write the answers for these kind of theory part also. I have given these questions purposely to remind the things, to get the things again and again from you. So don't skip the theory when you write the answers. Go through those theory also. Purposely, I have included those questions under my tutorial. So don't skip that. Sonometer wire resonates with the tuning fork when its length is 80 centimeter. When the sonometer wire is shortened by 0.8 centimeter, 4 beats are heard per second when the wire and the tuning fork vibrate together. What is the frequency of the tuning fork? Right? Okay. Sonometer wire resonates with the tuning fork when its length is 80 centimeter. For the question number 155. So you have the length as 80 centimeter now. It's vibrate with the tuning fork. Same frequency. Resonate means the same frequency. If you take the frequency of the tuning fork as F, the same frequency is F here. Now it is shortened by 0.8 centimeter. That means it's like L dash. Let's say L1. It is now 79.2 centimeter. So without going into detail, can one of you tell me when you shorten the length, Lamai? When you shorten the length, what happened to the frequency of that? Without going into any calculation, with the idea that you learn, it is increased. It is increased. Tapi isala question kalane. එතකොට දැන් ඔයාලට ටිකක් knowledge එකක් තව එකතු වෙනවා මේකෙදි. ඉස්සෙල්ලා කරපු questions වලම development තමයි හැමදෙස්සම questions එන්නේ. ඒක නිසා ඔයා තේරුම් අරගෙන කරුතින් එච්චර අමාරු නෑ මේ sections. It's increase, right? It's increase. Sonometer, yeah, 4 beats are heard. Let's say now the new length is 79.2 centimeter. 79.2 centimeter. And the new frequency of the wire is F1. F1. So when you reduce the length for this question, will the simple M or any capital T change? Capital T change or simple M change? Not change, right? No change. If it is changed, we have to they have to provide more details to get these answers. Since they haven't given any data, we can't take that as change. So we consider this as the constant figure, constant value. Right. Okay. With the basic idea, we can come up with F proportional L. That means F proportional 80 centimeter. Let's say number 1. So when you do the question, no need to convert into meters. The reason is we take a division. When you take a division, Lamai, it's cancelled. What is the frequency of the tuning fork? Okay. Second is for the second part, F1 proportional 79.2. Number 2. 79.2. Just take the division. Number 1 divided by 2. F divided by F1. 80. 79.2. දැන් ඕකෙන් මෙහෙම කරන්න යන්න එපා. මම කියන්නේ දැන් ඉගෙන ගත්ත ළමයි නෝනලා. මේක 80 ඊට පස්සේ මේක ආයේ 79.2 අරගෙන ඕකෙන් ආයෙ දාලා ඕක කරන්න ඕනේ නෑ. දැන් ඔයාලා knowledge එකක් තියෙන කට්ටිය. If I'm doing the very first day, I'm not doing that. I divide properly, but it is not required here because you have been learning this subject now almost more than 1 year. 1 year වලට වැඩි කාලයක් ඉගෙන දෙනවා මේ subject එක. ආයෙ level එකට යන්න ඕනේ නැහැ. F1. Anyone who has calculated this value? Can one of you tell me that answer? 79 divided by 2. 0.99. 0.99. So F equal 0.99 F1. Let's say number 3. Let's say number 3. In the second part, when those two vibrate, when this one and this one vibrate together, they are telling us there are 4 beats. So we know that it is F1 minus F must be equal to 4. Or else we have to consider F minus F1 lamai. Do we need to consider this one? Second stage, there are 2 possibilities. When you have beats lamai, there are 2 possibilities. F1 minus F equals 4, or else F minus F1 equals 4. But we can clearly remove this particular section because we know that F1 is more than F. Because when you reduce the length, the frequency should increase. So F1 is more than F, we neglect that. So like that, logically you want to get the exact equation. If not, you can't get the answer. Right. F equal then F1 minus 4. F1 minus 4. Let's say number 4. It make it F1 killing is F1 number 3 and number 4 are equal. F1 minus 4 equal 0.99 F1. That tells us 0.01. F1 equal 4. F1 equal 400 hertz. 400 hertz. So the F equal 396 hertz. 396 hertz. $156. Question number 156. The one is asking me if the decimal place changed by a very small value, even the entire frequency will change. You want to go only for the second decimal place. Don't go beyond that. Second decimal place එක ගත්තම වටින answer කරම answer එක. අපි ඔයාලා calculators use කරන්න එපා මේ government එකෙන් ආරම්භයෙන් දෙනවා කිව්වා. I don't know what is happening there. 155. So how you feel that when you compare with the mechanics and oscillation waves? Yes, much easy. It's easy actually compare with the mechanics. හොඳට ස්කෝර් කරන්න පුළුවන් සබ්ජෙක්ට් එකක්. හැබැයි ඒක ගොඩක් ලෙන්දි මේකද ඔප්ටික්ස් එකක් තියෙනවානේ. එක අවුරුද්දක යාලා essay question එකක් දුන්නොත් optics වලින් next year එකේ දෙන්නේ practical will be from the first part. ඊළඟ අවුරුද්ද දෙන්නේ ඕක අනිත් පැත්තට කරලා. හැබැයි එහෙම නොවන අවස්ථාවක් තිබිලා තියෙනවා. මේ අවුරුද්දේ optics essay question එකක් දෙනවා, next year also optics essay questions. කියන්න බෑ exactly, but we can guess certain things. Right, 156. One end of a wire of length 1 meter and mass 0.5 gram is stretched by a weight 5 Newton is tied to a prong of a tuning fork. Find the number of loops when the tuning fork is vibrated. Right, perpendicular to the plane of the wire, parallel to the plane of the wire. I have done that part under the theory. Right now we have a wire. We have a wire. It is connected perpendicular to the plane of the wire. It's vibrating like this, perpendicular to that. This is the tuning fork. It's vibrating perpendicular to that. So a wave would propagate along the median and reflected it back. We get a stationary wave. We get a stationary wave like this. Stationary wave like that. The length of that is 1 meter. And the mass is given 0.5 gram. The weight Newton. 5 Newton, sorry. 5 Newton. The tension is 5 Newton then. P equal 5 Newton. Tie to rod of a tuning fork, find the number of loops. We take the number of loops as n, let's say number of loops for the first part. Number of loops. And we have to calculate number of loops. If so, we can find the lambda. Lambda divided by 2 into n must be equal to 1. Lambda equal 2 divided by n. The one important relation we develop. One important relation we develop. So there is a small issue in this question, Lamai. What is that? Without knowing the frequency, we can't find the exact numbers. That is true. Without knowing the frequency of this, we can't find the exact number of loops. We have a small issue in this question. Make data it's not given. Yes. Yes, you are correct. The lambda equal this value. Okay. Second point. Yes, you are correct. The frequency V equal F lambda. V equal F lambda. V, it is T divided by root m. Root T divided by m. The frequency, let's say, if you have n number of loops, what is the harmonic number here? What is the harmonic number? If you have a number of loops. No, we can start like this. Frequency this is okay. Let's say f, I will take it as f 2 divided by n. 2 divided by n. Let's say number 1. Let's say number 1. We can calculate those two. How to calculate f? Yes, T and M is given. That's correct. That's correct. But they are not giving you the number of loops. Ne? Number of loops is not given. Have they given us number of loops? No, they are not giving number of loops. The make question again, perpendicular, find the number of loops when the tuning fork is vibrated. So my point is this, without giving the frequency of the tuning fork, initially also I thought that we can't find it without giving the frequency. It has to be provided, Lamai. Without knowing that, you can't find the number of loops. Here 2 divided by n. In the second instant, let's say we were given a kind of f කියන value එක දුන්නයි කියලා අපි හිතමු. Let's find these values first. 5 divided by n, it is 0.5 10 to the power minus 3. The mass divided by the length 1. F 2 divided by n. It is 5 1 10 to the power minus 4 minus 4 5 10 to the power minus 4 equal 2f over n. Here 1 10 to the power 4 2f over n. It is 100 2f over n. So the n equal f divided by 50. F divided by 50. Let's say the f is you can take f as 200 hertz. 200 divided by 50. It is 4. Ne? It is 4. It is 4. Can you please, there's a small issue in this question. Can you please write that right? That let's take the frequency of the tuning fork as 200 hertz. Without giving that, difficult to get the answer. Let's take frequency of the tuning fork. How can you approximate the frequency? You can't approximate the frequency. You can't do that. Let's say it has to be given. Type in Ranga Kathy. I couldn't take that question. It's a new question. Let's consider the frequency of the tuning fork as 200 hertz. 200 hertz. Let's consider the frequency of the tuning fork as 200 hertz. If you do like that, you get 4. If you vibrate parallel to the string, now the string is like this, you are vibrating parallel to that. So in that case, what happened to the frequency? What happened to the frequency? I told you, now the string is like this. Now the string is like that, right? You vibrate perpendicular to that. The string is kept in this plane. You are vibrate perpendicular to that. When you vibrate perpendicular to this, same frequency is transferred to the string. If you vibrate parallel to the string, parallel to the plane of the string, it is only half, because the tension is changed there, because at one instant the string slack. So only the half of the frequency would develop. Half of the frequency means number of loops should be how much? Half of this value. Half of this value. So number of loops, if it is vibrated parallel to the string, it is half. Just write under that. Just write under that. When the tuning fork vibrated, when the tuning fork is vibrated, parallel to the string, parallel to the string, parallel to the string, parallel to the string, the frequency of the wave is half of the frequency of the tuning fork, half of the frequency of the tuning fork, half of the frequency of the tuning fork, half of the frequency of the tuning fork. Right, okay. So the number of loops is 2, number of loops is 2. Right, question number 160. Question number 160. Question number 160. What do you mean by saying a node and antinode of a stationary wave? What do you mean by saying a node and antinode of a stationary wave? What is a node? Node is a point where we don't have any displacement, right? In a stationary wave, node is a point where we don't have displacement, right? Displacement is zero. Antinode, or you can say minimum. A node is a point where we have a minimum displacement of a particle. In that case, it is most of the time zero. In the second part, antinode. In a loop, we have a location, we are having the maximum amplitude. It is called antinode. Node and antinode are those two sections, those two things. Question number 160. An aluminium wire of length 0.6 meter is connected to a silver wire of the same area of cross section. Aluminium wire is given as 0.6 centimeter, 0.6 meter, so that the distance from the joint to the supporting pulley is 0.75 meter. A 5 kg mass is hanging from the composite wire. Stationary waves are produced in the wire by means of an external source given variable frequency. What are the maximum wavelength of the waves that can form on wires with the joint as a node? What will be the corresponding frequency of them? Mass per unit length of the aluminium wire is this, and the silver wire is this. Right, okay. Question number 160. It is a good question. We have 50 Newton, aluminium, silver, 0.6 meter. It is 0.75 meter. What are the maximum wavelength of wave that can form on wires with the joint as a node? Mass per unit length of the aluminium, 2.6 10 to the power 3 kg. It is aluminium, silver, 10 to the power 4, 10.4, 10 to the power 3 kg. Per meter. Probably it should be minus lamai. -3 can you place, please make it as minus. It can't be that kind of value. We will take that as -3. Okay. These 2 points, this point must be a node, this point must be a node, and this point should be a node. Do we know how many loops are formed there? According to the question, what are the maximum wavelength of the wave that can form on a wire with the joint as a node? When it's vibrated externally, external source, both wires are vibrating, start to vibrating. Do we know how many loops are there? Do you all aware about that? No, we don't know. We don't know about the number of loops. In that case, we know definitely this must be a node and this must be a node. This point should be a node. That is the basic idea we have. Apart from that, we don't have any idea. Let's say the number of loops in the aluminium wire and the silver wire as N1 and N2. Let's say we don't know the number of loops. There can be different numbers. Let's say this is N1, this is N2. N1, number of loops. number of loops in aluminium wire into number of loops in silver wire. Number of loops in aluminium wire, number of loops in silver wire. N1 and N2. If this is N1, this is N1, we can write the equation for the aluminium and silver wire separately. Tension is clear, 50 Newton. It is common for all the both aluminium and silver wire. Same tension must be maintained because the string is connected series. Same tension is maintaining, and the mass per unit length has to be changed. Let's say, let's take V equal F lambda for aluminium. For aluminium, V equal F lambda. V equal F lambda. V, it is T divided by M. F, it is the frequency of the tuning fork or the source. F lambda, when you take the lambda for aluminium, let's say lambda divided by 2 into N1 equal L1, which is 0.6 meter. Lambda equal 2L1 divided by N1. If I take this as V lambda 1, this must be lambda 2. It is 2L2 divided by N2. 2L2 divided by N2. Do we have the same lambda for aluminium and silver wire? Do we have the same lambda for aluminium and silver wire? No, we don't have like that. The reason, even though we have the same frequency along this string, both strings, we don't have the same lambda. The reason is the velocities are different. Tension is fixed, yes, but mass per unit length is changing. Here, the lambda equal to L1 divided by N1. Tension T, M1, M aluminium, frequency F, 2L1 divided by N1. Let's say number 1. For silver, I'm using the same equation. I can start like this and similar pattern. M silver equal F into 2L2 divided by N2. This is number 2. This is number 2. 1 divided by 2. 1 divided by 2. M aluminium, M silver. Take the root of that. M aluminium, M silver. When you divide by that, 1 divided by 2, M aluminium, M silver equal F cancel. L1 over L2. L1, L2. Here N1, N2. Check whether you got the idea. You got my point. N1, N2. N1, N2. Now we can substitute the values. M aluminium and M silver. M aluminium. M silver, it is 10.4, 10 to the power minus 3 divided by 2.6, 10 to the power minus 3. Root of that. L1, it is 0.6. L2, it is 0.75. N2 over N1. It is cancelled. 10.4, 2.6, that is 4. Root 4. It is 4 divided by 5. N2 over N1. This is 2. 4 divided by 5. N2 over N1. So that is 2 and that is 1. N2 over N1 equal 5 divided by 2. 5 divided by 2. That is the ratio between the loops, number of loops. For example, when this one having number of loops 5, the number of loops there is 2. If you have 10 here, how many number of loops would be there? How many number of loops are there? I develop kind of ratio between that, it must be 4. If you have 15, this must be 6, like that. But anyway, we know the minimum ratio between the loops. When it's 5, it is 2. When it's 10, it is 4. When it's 15, it is 6, like that. Okay. So those are the number of loops you should understand. 5 to 2. The ratio is 5 to 2. The next important thing you should understand, if the number of loops are decreased, if the number of loops are increasing, what happened to the wavelength? When the number of loops are increasing, what happened to the wavelength? Sorry, the frequency? No, the wavelength, what happened to the wavelength? When the number of loops are increasing, what happened to the wavelength? The one is asking me, but no, you can't take like that. They are asking for the maximum wavelength, can't just take it as a one loop for one section. No, you can't take like that. That is what I am doing here. You can't take like that. If it is one, it is not one. It's different. So what we develop is the ratio between the loops. The next we have to develop a logic. Are we taking this number or the different number? So that's what I'm trying to help here. That's what I'm trying to do here. Just tell me, when the number of loops are increasing, what happened to the wavelength? Decrease or increase? When you have more number of loops, what happened to the wavelength? What happened to the wavelength? Decreases. Even from there, you can understand, when you have more number of loops, the lambda is decreases. When you have more number of loops, lambda decreases. So that means maximum, for a maximum wavelength, we should have minimum number of loops. Minimum number of loops. We develop the minimum ratio between the silver and the aluminum wires. Minimum number of loops, the ratio between the aluminum silver wires, it is the minimum value. So that tells us this is the maximum wavelength which can be obtained from these two wires when it vibrated simultaneously. When you vibrate simultaneously, you get the maximum number of minimum number of loops means that tells us we are referring to the maximum wavelength. Am I correct? Clear? Okay, right. Can you come to this point? I have something to write. 5/2. It's a good question. Okay, I have to come to this location. Right, just right under that. When the number of loops are increasing, when the number of loops are increasing, when the number of loops are increasing, the wavelength reduce, the wavelength reduce, the wavelength reduce. So to obtain, therefore to obtain the maximum wavelength, therefore to obtain maximum wavelength, therefore to obtain maximum wavelength, we should consider minimum number of loops, minimum number of loops, minimum number of loops, minimum number of loops. Minimum number of loops. Right, minimum number of loops, right? Okay. Right, we will find the wavelength now, lambda 1. Can you try that? Lambda 1. What is the value of the lambda 1? Lambda 1 equal to L1. It is 0.6 divided by N1. N1 it is 2. Lambda 1 equal 0.6 meter. Lambda 2, 2L2, L2 0.75, N2 it is 5. Lambda 2 equal 0.25, no 0.15, which is 0.3 meter. It is 0.3 meters. N1 it is 0.6, N1 it is 2, while the other become 5. Right, done? Right, number 2. Number 2, what will be the corresponding frequency then? What will be the corresponding frequency? We can calculate it from either aluminium or silver. For the aluminium, for aluminium wire, V equal F lambda, V it is T divided by M, f lambda f equal lambda tm if it is 0.6, tension it is 50, aluminium 2.6 10 to the power minus 3, f equal 0.6, 50 10 to the power 3 divided by 2.6 frequency. What is that value? Anyone calculated? $138 into 0.6, 83.2. It is 83.2 hertz. This is the frequency of the wave which propagate through the aluminium and silver both wires. It's the frequency of that wire. I will move to another question. Right. Okay, finish, done. Right. I will move to another question. Question number 207. Question number 207. I take 10 to the one is asking me why I take 10 to the power minus 3 in my calculation. So normally you should understand it's a string. It's a string, right? It's a wire. How can this kind of mass is there? Practically, you can't have a value like 2.6 10 to the power 3 kg per meter. It's a very impossible number, not practical part, practical thing. So this must be minus 3. There can be some typing error. So I thought that must be minus 3. Okay. We will move to the question. Just read the question. Right, question number 207. Read the following passage carefully and answer the question given below. The source of any sound, including musical notes, is vibrating object. A sound is characteristic by its loudness, its pitch, and also the third property called quality. Quality of sound enables us to distinguish a given type of musical instrument from other, right? For example, when a note is played separately in the violin and flute with the same loudness and the pitch, there is a clear difference between the two sound hertz. This is due to the difference in quality of sound of these two instruments. So mainly there are three factors you should understand for the sound to differentiate. One is the loudness, other one is the pitch, other one is the quality, which is called timbre. The loudness is depends on what? The loudness is depend on amplitude, pitch is depend on the frequency, quality depends on the number of harmonics present in a given note. So those things we discussed earlier also. Just as loudness, the pitch can be related to measurable physical quantities of the sound waves, so too can be quality. Generally, when a note is played in a musical instrument, overtones are present in addition to the fundamental frequency of the sound. Quality of sound depends on the number of these overtones and their relative amplitudes. I have done that part also, relative amplitude and those things we discussed. Figure 1 shows a sound pattern of a note produced by a violin. They have given this kind of pattern. Actually, how we get that? It is the addition of fundamental. If you take that as a fundamental, within this fundamental, few overtones can be produced. It's a one thing. The second harmonic or third harmonic. Let's say we have another one. Like this. So the summation would be this. This is the addition of that. Make a result. Figure 1 shows the sound pattern of a note produced by a violin. It indicates variation of total amplitude of the sound produced by the instrument with the time. Figure 2 shows the Fourier spectrum of this sound pattern, giving the frequency of its fundamental and the overtone. They are relative amplitudes. The Fourier spectrum is generally from sound pattern using mathematical techniques called Fourier analysis. It contrasts to the musical note sound, which are normally called noise, have clearly continuous Fourier spectra rather than discrete spectra. Today we have electronic organs that can reconstruct music produced by any musical instrument available to us. For such reconstruction, the first Fourier spectra of the musical note must be obtained. After that, it is possible to electronically generate an electric wave pattern for each note by mixing electrical signals. So, for example, we want to develop the flute sound from the organ. So we develop the Fourier spectrum there, and we consider the relative amplitude with the frequencies and develop electrical signals, and they mix together to form the sound as for flute. In a standard musical instrument, the source is said to vibrate by striking. It is not bubbling, it must be blowing. B-L-O-W-I-N-G. B-L-O-W-I-N-G. Blowing, plucking, or bowling. Among the common musical instruments, the drum has membranes that vibrate then when stopped. The flutes and the trumpet make us vibrating a column of air to produce musical notes. Flutes can be considered as a tube with both ends open. The flute can be considered as a tube both ends open. When the flute is played, the air inside it resonates. While in guitar, piano, all are vibrating straight strings. In a guitar, different musical notes are obtained by varying the vibrating length of the string using fingers. You know that, no? And the guitar has several such strings to produce all required notes. In piano, there's a separate string for each note. In piano, we have a separate string for each note. When you play C, we have a separate string. D, separate string. C sharp, different string. In general, the mechanical vibration in thin string do not produce sound loud enough to hear directly. In string instrument, therefore, the sounding box is used to amplify the sound. When strings are set into vibration, the sounding box resonates. The same sound pattern produces much stronger sound. However, in electric guitars, mechanical vibration of a string is converted to electrical signal, which is subsequently amplified electronically. Right. I think you might read this paragraph 2 3 times. I think like that. I need to understand that paragraph. Uh, since I have done the theory behind that, it is not difficult to understand. Like number one, what physical property of sound wave determine the loudness of sound? What is that? It is the amplitude of the wave. Amplitude. Sound එක determine කරන්නේ amplitude එක මත. When you have a large amplitude, you have the large loudness. Amplitude of the wave. Amplitude of the wave. What physical property of sound wave is associated with the pitch of the sound? What is that? It is the frequency. Frequency. Very simple question. The fundamental frequency of F naught of the Fourier spectrum of the violin shown in figure 2 is 400 Hertz. Fundamental frequency given as F naught 400 Hertz. What is the frequency of the third overtone produced by the violin? Third overtone. Third overtone, F naught fundamental. Second F naught means the first overtone, second overtone, third overtone. In terms of harmonic number, what is that? In terms of harmonic number, what is that? What's your answer? Then මේ violin එකේ Fourier spectrum එක දීලා තියෙනවා. If you take this as a fundamental, F1, F2, the values are given in different way. 2F0, 3F0, 4F0, 5F0, like that. What is this? This is the fundamental. What is this in terms of overtone? What is that? First overtone, second overtone, third overtone. This is our third overtone. Third overtone means fourth harmonic. What is the frequency of the third overtone produced by the violin? What is that? For the number 3, in question number 207, third overtone, it is what? Third overtone means fourth harmonic. 4F0, 4 into 400, 1600 Hertz. What is the value of amplitude of the fifth overtone? Fifth overtone means sixth harmonic. One, two. We have two numbers. Amplitude of the fifth overtone to amplitude of the fundamental frequency. Amplitude of the fundamental frequency. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like 10, eh? 10. You have 2, you have 10 here. For the A, for the B, we have amplitude of the fifth overtone, it is 2 numbers. In here you have 10 numbers, that means 0.2. Understood? Clear the okay, the lamai. Clear or not clear? Right, okay. Number 4. We will move to number 4. A note produced by a musical instrument has a fundamental frequency at 420 Hertz. A note produced by a musical instrument has a fundamental frequency at 420 Hertz. And the first and the second overtone each having amplitude equal to 1/2 of that fundamental. Assuming that no other overtones are present, draw the Fourier spectrum of the note. First and the second overtones each having amplitude equal to the 1/2 of that fundamental. Think about that. 1/2 of that fundamental. Half of the fundamental. If you take this as a fundamental, if not, F1, F2. Can you see my board? This is the frequency. So when you draw that, make sure to mark this axis. Frequency, relative amplitude, relative amplitude. Relative amplitude, I should draw it fundamental here. 1, 2. F naught. F naught is 2 times compared with these two. We don't know whether F1 is 2 F naught, 3 F naught. We don't know. We just draw the F1, F2 as the overtones. ඊළඟ frequency එක අපි දන්නේ නැහැ කොච්චරද කියලා. හැබැයි relative amplitude දීලා තියෙනවා. Amplitude වල values දීලා තියෙනවා. ඒ කියන්නේ මෙයා value එකෙන් half. I know, no issue. You have taken this as 6 නේ. මේක 6 අරගෙන මේක 3 3 කියලා දිනවනේ. හරි, okay, no issue. Right, no problem. ඒ කියන්නේ මේ value එකෙන් half වෙන්න ඕන කියන විතරයි base කරන්නේ එතනදී. Right, number 5. State the steps that should taken to electronically generate the sound described in part 4. What we have to do, we want to generate electrical signals comparing their frequencies and the relative amplitudes. They ask us how to electronically generate that. The part A and part B I described name. Part A and part B. So you should again look at my video. I have already described the part A and part B. Number 4. Number 4. If you have anything, you can ask me if you can't understand, because I have only limited time. If I start to repeat it, it's difficult for me to complete the other part. Number 5. Number 4. State the steps that should be taken to electronically generate the sound described in part 4. What we should do, we should consider those three frequencies with their relative amplitude. Electronically, we should generate those 3 signals and mix together to produce the sound which we need, right? What we want to write there, consider their corresponding frequencies with their relative amplitudes and mix together electronically to generate that required sound. Okay, just write under that 3 electrical signals having frequencies, 3 electrical signals having frequencies F0, F1, F2, and respective amplitudes and respective relative amplitudes and respective relative amplitude 1, half, 1, half, are superimposed to generate the sound. Superimposed to generate the sound. Right. Number 6. Electronic guitars have no sound in box. Give the reason. Electronic guitars, what we have? Sound in box is used as amplifier. Electronic guitar, we have electronic amplifiers. That is the reason. We have electronic amplifiers. Just write under that. In electric guitars, the sound of the strings the sound of the strings are amplified electronically. Amplified electronically. Number seven. Write down an expression relating the length L, tension T, mass per unit length M, the fundamental frequency F0 of a vibrating string. You can straight write that 2L T divided by M, fundamental frequency. F0 is this. Number 8. 0.68 long guitar string is tuned to play a note of fundamental frequency 330 Hz when unfingered. You have a string 0.68 meter, vibrate is fundamental. The frequency here is 330 Hz. How far from the end of this string must the finger be placed to play a note of fundamental frequency 440? Let's say this is the location. When you place your fingers here, the part is not vibrated, only this part is vibrated. Let's say it is L1. Now the new frequency here 440 Hz. So we don't want to tell that T and M are remain constant because the guitar string, the tension and M is not different when I compare those two instances. Frequency is proportional to 1 over L. F0 330 proportional 0.68. Let's say number 1. 440 proportional L1. Number 2. 2 divided by 1. No, 1 divided by 2. 330, 440, 0.68 L1. It is 1, 1. It is how much? When you divide by 11, 3 divided by 4. Yes, 3 divided by 4, 0.68 L1. Again, cancel point. How much? 17. L1 equal 0.551. 0.51. So you want to comment, we have to place our finger at a distance 0.51 meter from the one end. From one end. Then may distance must be how much? 0.68 minus 0.51. You can say 0.17. May 0.17. May 0.51. So when you draw that and come to that answer, they would understand this is 0.51. Number 9. A flute is designed to produce a note of fundamental frequency 262 Hertz. It is Hertz. Huh? A flute is designed to produce a note of fundamental frequency 262 Hertz when played at 27 Celsius with the all hole closed. Right? Fundamental frequency. In this question, they mentioned both ends are open. The flute can be considered as a tube which both ends are open. Now the fundamental frequency is 262 Hertz. The Celsius, 27 Celsius. If the speed of the sound in air is 340, now the velocity of the speed is 340 ms minus 1. Calculate the approximate length of the flute. Let's say the length of the flute as L. Length of the flute as L. When you draw that, and no need to write, it's a passive question. When you draw like that, no need to say that the length of the flute is L. They could understand that this is what they are referring. Right. Let's say that is length L. Lambda divided by 4 into 2 equal L. Lambda equal to L. Lambda equal to L. We don't want to think about the end error. The reason is it is not question. So we assume that end error is negligible. Lambda equal to L. Now V equal F lambda. V equal F lambda. The velocity is given 340. The frequency 262. Lambda it is 2L. L 340 divided by 262 into 2. Anyone calculated that? .64 meters. Okay. If the flute played with all holes closed in a place where the environment temperature is minus 30, what will be the fundamental frequency of this sound? Now, the temperature is changed. Temperature is changed to different value. Now the temperature is minus 30 Celsius. Minus 30 Celsius. Minus 30. Minus 30 Celsius. V equal F lambda, right? The velocity now changed. The reason is velocity depend on the room temperature. Velocity change depend on velocity change different compared to the room temperature change based on the room temperature. V equal F lambda. F lambda equal then V, which is equal to gamma RT divided by M. Gamma RT divided by M. So the lambda won't change. We are referring to the same fundamental. The length won't change, lambda. F proportional. V proportional root T. Okay. For the first instant at 27 Celsius, F it is 262 proportional 273 plus 27. Remember, this is absolute temperature we want to take. Number 3. Number 3. In the second part, at minus 30 Celsius, let's say the frequency as F proportional 273 minus 30. Let's say number 4. I hope everyone could understand that. The reason is V equal F lambda equal V, which is equal to gamma T over M, F proportional root T. Root T. 4 divided by 3. F divided by 262. 273, it is 243 divided by 300. F 262. 243 divided by 300. What is the value? Anyone calculate it? Yes, 235.4 hertz. This is the answer. 235.4 hertz. 35.4 hertz. This is the answer. Okay, 207 also I discuss.